Anybody in math, grades, whatever, have you ever been taught the formal names of this? But I'll tell you, the first math class in college, I had to name them. They would give me examples, and I had to name them. Isn't that crazy? Okay, all of a sudden, I had no idea, so I had to learn them. And you need to know what they are and that they're available to you. So commutative, you're just obviously switching your numbers, okay, and adding. Commutative property of multiplication, you're just switching your numbers, but they're saying that if you took 5 plus 3, it's the same as doing 3 plus 5. That's essentially what that means in abstract terms of variables. Associative says you can just put your parentheses. As long as you're adding, you can put your parentheses around any two, and it's going to give you the same answer. Associative for multiplication, same scenario. If your identity property of addition, you add 0 to anything, it's going to give you the same thing. Identity property of multiplication, you multiply times 1, it's going to give you the same thing. So you've been using these, you just didn't recognize the names for them. Inverse, and we use this and this and this and this and this and this a lot in algebra, okay? So that's why I kind of give you this sheet. It is just a note sheet, but guess what? Then we come over here and we're going to look at it, okay? So let's look at what we've got, an example, and let's try and name the specific property, okay? This says if you have A, all right, and you multiply it times B plus C, it's the same thing as taking A times B plus A times C. Do you have any idea what that is? No, sir. Look on your notes. There's a perfect example of it. It's just written a little bit different. Nope. Distributive. In other words, what has happened here is this A has distributed the multiplication times B and the A times C, and you'll get the same answer no matter how it's written, okay? So this is known as the distributive property. I guess if I spelt it right, it would be great. Distributive, okay? And it's really the distributive property of multiplication, okay? But you won't get a distributive property of addition, all right? Then the next one, what is that? If I add 0 to anything, I get the same answer. Identity of what? Right, so it's identity, and I'm just going to simplify this and put for addition, okay? Because you know, I'm trying to use shorthand. A times B is equal to B times A. Which one was that? Commutative. Of multiplication, correct? All right, now you've got a -1 times -4. So anything that I need to change to positive, remember we're going to multiply by -1, and it gives us the positive, or the what? Well, it's not really. The inverse is when you flip it, okay? That's the inverse, all right? The inverse is if you took, let's say you took 4 times 1/4, okay? 4 over 1 times, what would be a good example of inverse? 5 times 1/5, because you would end up with 1, correct? So you're trying to get to the inverse of 1/5, all right? This is more of the, it's just the property of -1, that anytime you take a negative times a negative, you get a positive. And instead of teaching you the name for it, they just tell you the rule is a negative times a negative gives you a positive. Well, this is actually the multiplication property of -1. Okay? Then you have this one. If I take 5, now this is an inverse, okay? This is an inverse. So in addition, it's called inverse, all right? So inverse of addition. Now what's that? Inverse of multiplication. All right, we just moved the parentheses, so it is, in other words, instead of doing them in order, now they're telling you to do what, these two first, then multiply it by this, right? Then they just changed it and said do these two first and multiply it by this. You're going to get the same answer, so what is that called? Associative. And you'll always see those parentheses in associative. And this is of multiplication. Okay? Now, what about this? Commutative, okay? Of addition. You just switch the order. Commutative of addition. Okay. What would that be? That's right. Multiplication property of 0. Okay. Then we've got this one. Identity of multiplication. And then you have this one. Anytime you see those parentheses and all the numbers are the same, what is it going to be? Associative, and this time it's of addition. Okay? So identify the specific problem for each example. What would you say for the first one? Now, are they in the same order? And isn't z plus y here and y plus z here? Look at that. All they did was flip the what? Order of these two pairs, right? So if we just flip the order, what is that called? Yeah, that's a really tricky one. Okay. Commutative, because here I just told you if you see the parentheses, that wasn't fair of me, was it? Commutative of addition. Okay. Ooh, look at that one. They're in the same order. So if they're in the same order, what do we want to call it? Who said it? I thought I heard it. Associative. They're in the same order. So commutative, you're going to change order. Associative, you're going to keep the same order. Okay? Ooh, what happened here? Distributive property of multiplication. And what it's the long name for it is distributive property of multiplication over addition, because you're really doing both, aren't you? Okay, you're distributing your multiplication over an addition problem. Okay, all right, what do we got here? That one's just too rough. It's distributive property, but don't worry about it. Okay, that's like craziness. Okay. All right. So now we have some notes on the back. Now we get into the meat. And most of this you've done before. I am going to require you to show me a check. Okay, and it will be on your work. So solve and check the following equations. 4x plus 6 equals 14. What's your first step? Subtract 6 from both sides. And we've done this. And you get 4x is equal to 14. Take away 6 is what? 8. Okay. And it's on the back of the other one. It's on the back of this one. Okay? And so then I'm going to divide by 4, and I get x is equal to what? 2. Okay? All right, number 2. I'm going to put your negative 1 here so that we don't forget about it. We're going to subtract 7 from both sides. Both of these are fairly simple. Okay, then you've got negative 1p is equal to a negative, and a negative gives you a negative 21. Okay, now can I leave my p negative? No. So what am I going to do? I choose to multiply by negative 1. You can divide by negative 1. It doesn't matter either way. And that changes it to a positive p is equal to a positive 21. Now, to do my check, all I have to do is come over here and do negative 1p plus 7 is equal to negative 13. I said p is a positive 21, correct? So negative 1 times 21 plus 7 is equal to negative 13. I get negative 21 plus 7 is equal to negative 13. I find that opposite signs, the rule is ignore the signs, take the larger number, subtract the smaller number. I end up with 13. Keep the sign of the larger number, and I get negative 13 is equal to negative 13, and that gives me a check. What? Okay. If they are equal to each other, then that is a correct answer. If they do not equal to each other, then it is an incorrect answer. Okay?
But wouldn't negative 21 plus 7 equal negative 14?
What? 21 minus 17. 7.
Yeah.
Ooh, where'd I go wrong? 13 minus 7 was wrong, right? 13 and 7 should have been 20, huh? On the problem when I worked it? Look at that. Look at that. My bad, your bad. Didn't catch me. Huh. You wrote 20, so why didn't you say anything? Because you were being nice? Huh? Because you were being nice? So, what should have happened is when we had negative 13 and negative 7, what should we have gotten?
20. I get 20.
Negative 20. Good catch. Okay? And here I keep professing that I'm perfect. Ah! We won't tell my husband about that, though, okay? Alright, so this should have been 20 and 20, and this should be 20, and this should be 20. Then that would make this what?
True.
13, which is true. Correct. Check. Okay. The reason I handed you a piece of paper is because we've got these inverse operations, and I know that we've done them because you and I have done them, but we're going to look at it a little more. 9 equals r over negative 3 plus 4. Okay? What's in front of the r? 1. Does it bother you that my 9 is on the left? If it does, all you'd have to do is sit there and rewrite it. You could write 1r over negative 3 plus 4 is equal to 9. Okay? Same equation. So if it really bothered me, because I've had some students that it bothers, and I tell them just go back over here and write it like this. Okay? All right, so we're going to work it this way, though. So this is what I've got. What do I need to do? I need to get rid of that fraction. Well, you want to subtract 4 first? All right, we can subtract 4 first. Either way. That probably should do that. Probably get constants together first. That would make sense. So now I've got 1r, negative 1r over 3 is equal to, opposite signs, 9 take away 4 is 5. And it's positive. Okay? So now, what am I going to do? Have you divided? Now that's a whole heck of a lot of thought. You can divide by negative 3, but I'm telling you one thing that's easier. Just multiply by negative 3 over 1. Okay? Multiplying with a fraction, you don't have to worry about remembering to flip. You don't have to remember to, and then I also know if I do one side, I got to do the other. But the other nice thing about this is then you know that this cancels this, and you're done. You know what I'm saying? Okay? If you have something where you're trying to divide this, you would be writing it like negative 1r over 3, and now I'm going to divide that whole thing by negative 3. Doesn't that look really complicated? Maybe not to you. I don't know. I find it easier just to multiply. If you find it easier to divide, and dividing 5 by negative 3, I don't think we're going to get the right answer, are we? So you'd have to divide by negative 1/3, actually, I think, to get the right answer, wouldn't you? You'd have to do negative 1/3 divided by negative 1/3. But then if you had negative 1/3 over here, you would have to flip it because it's a fraction. You get into all kinds of issues. You don't want to have to do that, okay? Because if you have 5 divided by negative 1/3, don't you have to flip this and do 5 times negative 3 over 1, right? It's way more complicated to do that than to just multiply by the inverse, okay? And that's why we have that property and why it works so nicely. So if I have a negative times a negative, what am I going to end up with? A positive. So then I've just got positive r, and I've got negative 3 times 5. That's an easy one, isn't it? Negative 15. Now, let's do our check. Okay, so I'm just going to do this because I'm going to do my check on this side. I'm going to rewrite 9 is equal to 1r over negative 1r over 3 plus 4. I've got 9 is equal to negative 1 times negative 15, right? Because I'm substituting it in, over 3 plus 4. I've got 9 is equal to, what What are you gonna do? Okay, let's subtract 4. Then what would you have? You'd have 15 over 3 is equal to what? Positive 5. Okay? This is what will blow your mind. I take this side, multiply it by 3 over 15, but I'm not coming out with a negative. Why not? Why am I not coming out with a negative? No. Oh, because it was. This was on the outside. This was on the inside. So I had no, because it would still be like saying negative 1 times negative 15, which would give me a positive, right? Correct? Okay, let's figure this out. We got to figure this out. Because that doesn't, I have it here, and I did it here, and I didn't do the check, and there's got to be a reason why I didn't do the check, because I didn't like the check, did I? Okay, so I did this, we got negative 15, that was correct. We got to figure this out. We got to get it right.
Mathematicians.
No. Why didn't I do that? Does not make good sense. You should all make hundreds in this class. I've done something wrong somewhere, and I'm trying to figure out what it is. Alright. Well, you're just gonna have to, I'll have to work it out when I'm on my own and I'm not thinking with you guys. Alright, let's go over here to number 4. Okay? So my answer for number 3 is r is equal to negative 15, and I'll figure it out and get back to you. Okay? Alright, here we go. Number 4. I've got negative 4 thirds and minus 2 thirds is equal to 5 6. Okay? What's the first thing I have to do? Let's add 2 thirds to both sides. How about that? Okay? If I add 2 thirds to this side and I add 2 thirds to this side, I end up with negative 4 thirds n is equal to, alright, I'm going to come over here. I got 5, I know, I'm going to use this for my check too, but 5 6 plus 2 thirds. What do I need? Common denominator, right? So this is 6. I get 4 6 and 5 6, which gives me how much? 9 6. So now I've got 9 6 on this side, and it's positive. Everybody agree? Okay. Are we good so far? Okay. So now, what can I do? I can multiply by what? Negative 3 over 4. This side by negative 3 over 4. Okay. These cancel. I end up with n is equal to, what's 9 times 3? 27. And I'm going to end up with a negative. What's 6 times 4? 24. Now, do they have anything in common? 3s. So, 3 goes into 27 how many times? 3 goes into 24 how many times? There's my final answer right there. Okay. You good? Maybe? Negative 9/8. So n is equal to negative 9/8. If I didn't simplify, would it be correct? No. Okay. It would not. Do I dare try to check? Want me to try to check? Let's try it. All right, check. Negative 4/3 n minus 2/3 is equal to 5/6. All right, negative 4/3 times negative 9/8 minus 2/3 is equal to 5/6. I'm going to do my multiplication first, all right? Negative times a negative is going to give me a positive. 9 times 4 is 36, and 3 times 8 is 24, correct? Everybody got me with that or no? You good? I'm sorry. Minus 2/3 is equal to 5/6. Okay, so, and that's where I went wrong with the last one. I can tell you that right now. Because what I did over here on this check, I subtracted. I'm not supposed to subtract 4. I need to just do this equation and see if it equals 9. Does that make sense to you? Just figured out what I did wrong. Okay? All right? That's why it didn't work. Okay? So, what I need to do here is to get these in a common denominator, correct? So, if I have 2/3 and I want them to be 24, 3 times 8, do you agree? 2 times 8 is 16. So now I have 36 over 24 minus 16 over 24, and I get 5/6. 36 minus 16 is 20 over 24 is equal to 5/6. Guess what? Simplify this and divide both by 4, and I'm going to get 5/6 is equal to 5/6. Do you agree? Because 20 divided by 4 is 5. 24 divided by 4 is 6. I get 5/6. See how I did it? What I did the last time was I tried to work this as if it had a variable in it. It doesn't have a variable in it. All I needed to do was clean the first part, this side up, so that it will get to this side. Okay? My bad. No, I'm the one who listened and wasn't paying attention to what I was doing. Okay? Don't look bad over that. All right? So it checks. All right? All right, number 5. Decimals. 2.5x plus 3.9x minus 7 is equal to 23.8. All right, let's combine our x's. I got 2.5 and 3.9. 14 carry 1, that's 7.4. Everybody agree with that math? 14, nope, 5, 6. It's 6. Here I'm doing multiplication. 6.4x minus 7 is equal to 23.8. So add 7 to both sides. 6.4x is equal to 30.8. 30.8 divided by 6.4. Move this over 1. 64 goes into 308. Let's see, 60 and 60 is 120. So 120 and 120 would be 240. That would be 4. I'm going to try 5 times. 64 times 5. 20 carry 2, 32. Too much. So it's going to go 4 times. All right. 4 times 4 is 16, carry 1. 4 times 6 is 24, 25. 256. I get 2. Borrow, I get 52. Add a 0, 520. That was what I got the last time, huh? So it's going to be 4.5, 520. So x is equal to 5.2. Or 4.5, I'm sorry. Okay. You guys good with decimals? Yeah? I'm so glad. Alright, here's the deal. It's time. You've had some of those skills in 8th grade math now, but you have not had all of those skills in 8th grade math. Who needs to check out a calculator from me? Anybody? No? You're all good? I have calculators you can check out. Nobody needs one. You have the app. Hector, you don't need one? You don't need one? You don't need one. You're okay? You have one at home? Do you need to check one out? What? I think so. Good. You can't be shy around here. You gotta state what you need. Okay? Alright. You may check your work with the calculator. Okay? Alright? Now, I'll teach you one trick really quick that might help you. Okay? But you've got to show what you're doing. You can't just, this one looks fine. Number 1. Okay? Alright. If you have a fraction that you need to multiply, okay, or add, always put parentheses around it in your calculator. Okay? Otherwise, it wants to do the division. Okay? Because it recognizes the fraction bar. You're putting in the division sign, right? So, parentheses 1 divided by 8, parentheses plus, parentheses 2 divided by 7, parentheses, and then you can hit math, enter, enter, and get a fraction. Okay? Don't leave me decimals unless the problem is in decimals. Leave me improper fractions. I'm okay with that, but simplify. Alright? Okay? Alright, everybody okay with that? Alright? And that should help you. Okay? So, start using your calculators. Okay? Check your work. And use that to help you with your integer issues, with your division issues, your fraction issues, and check